Imagine Earth, our beautiful blue marble, peacefully floating in the vast, dark emptiness of space. It seems so tranquil, so safe. But what if I told you that at any moment an invisible, silent killer from across the cosmos could erase all life as we know it in an instant? This isn't science fiction. This is the reality of gamma-ray bursts. Forget supernovas. A gamma-ray burst, or GRB, is the most powerful explosion the universe has ever known since the Big Bang itself. In just a few seconds, a single GRB can release more energy than our sun will in its entire 10 billion year lifetime. And the most terrifying part, you'd never see it coming. These bursts are primarily composed of gamma rays, a form of light so energetic it's completely invisible to our naked eyes. They're silent, unseen hunters prowling the cosmic darkness. So, what would happen if one of these cosmic assassins had Earth in its sights? The result would be nothing short of planetary sterilization. Imagine a colossal star, many times more massive than our sun, running out of fuel at the end of its life. Its core collapses under its own immense gravity, forming a black hole. As the star's outer layers fall inward, the new black hole devours them, launching to unimaginably powerful jets of energy and particles into space at nearly the speed of light. This is a long-duration GRB. If Earth were unlucky enough to be in the path of one of these jets, even from thousands of light-years away, the consequences would be immediate and catastrophic. The moment the burst hit our upper atmosphere, it would be like a cosmic blowtorch. The intense radiation would instantly obliterate our planet's ozone layer, the fragile shield that protects us from the sun's deadly ultraviolet radiation. Without the ozone layer, lethal UV rays would pour down, scorching the surface of the Earth. Within seconds, 2 minutes, life on the sunlit side of the planet would be exposed to radiation levels equivalent to a global nuclear war. It would trigger a chemical reaction in our atmosphere, creating thick, reddish-brown clouds of nitrogen dioxide, blocking out the sun and plunging the planet into a sudden, deep freezer kind of cosmic winter. This would also lead to intense acid rain, poisoning our oceans and soil. The combined effects radiation, global cooling, and acid rain would trigger a mass extinction event on a scale we've never seen, wiping out the food chain from the bottom up. It's not a slow burn. It's an instant apocalypse delivered from across the galaxy. There's another fastest type of DRB, short duration burst. These are thought to be caused by the collision of two ultra-dense objects called neutron stars. As thesicity-sized stellar corpses spiral into each other, they merge in a violent explosion that also unleashes powerful jets of gamma rays. While shorter, lasting less than 2 seconds, they are no less deadly. This brings us to a chilling event that happened just recently. In 2024, astronomers detected a powerful gamma-ray burst. While it was thankfully thousands of light-years away, it was a stark reminder of the cosmic shooting gallery we live in. This particular burst, let's call it GRB, 240,412, erupted from a distant galaxy. When scientists traced its trajectory, they found that its beam of death was pointed just slightly away from our direction. It was a cosmic close call. If the orientation of that collapsing star or merging neutron stars had been just a fraction of a degree different, that jet of unimaginable energy could have been aimed directly at us. What's a bed does. In this case, it was pure, dumb lack of alignment. The universe is a three-dimensional space, and these jets are relatively narrow, like a cosmic sniper rifle rather than a shotgun. For a GRB to affect us, Earth has to be staring right down the barrel. The beam has to be pointed directly at our solar system. Given the sheer size of the universe, the odds of a direct hit are low, but they are not zero. Astronomers estimate that a dangerous GRB could occur in our own Milky Way galaxy every few 100,000 years, and a direct hit could be what is responsible for some of the unexplained mass extinctions in Earth's distant past. So, what protects us from this constant, looming threat? Our first line of defense is distance. Space is incomprehensibly vast. Most GRBs happen in galaxies that are millions or even billions of light years away. By the time their energy reaches us, it has spread out so much that it's harmless, becoming just faint whispers of data for our telescopes to detect. Our atmosphere and magnetic field also provide a crucial shield. They are remarkably effective at absorbing and deflecting a lot of cosmic radiation from space, including the background chatter from distant cosmic events. However, these defenses would be utterly overwhelmed by a direct hit from a relatively close GRB, say, one within our own galaxy. Even a near miss, where we only get grazed by the edge of the beam, could have serious consequences. It could disrupt our satellites, knock out global communications and power grids, and cause temporary but significant damage to the ozone layer. We wouldn't be sterilized, but it would be a major global crisis. Our technology, in many ways, makes us more vulnerable to the secondary effects of these cosmic blasts. This all leads to a profound and humbling realization. We live under a cosmic gun. The universe is not a gentle, nurturing place. It's filled with forces of unimaginable power and violence, and our existence is, in many ways, fragile and contingent on cosmic luck. It raises some big existential questions. As we look for life on other planets, we have to consider this. Maybe the universe is silent not because life is rare, but because planets with life are periodically scoured clean by these invisible bursts. Perhaps countless other worlds, once teeming with potential, weren't as lucky as we've been. Maybe they were in the wrong place at the wrong time. This is why the work of astronomers and astrophysicists is so critically important. Every time we point a telescope to the sky, we are not just looking at pretty lights. We are scanning the horizon for potential threats. We are trying to understand the rules of this cosmic neighborhood we live in. By studying GRBs, we learn about the life cycle of stars, the birth of black holes, and the very fabric of the universe. But we also learn about our own vulnerability. The universe is both beautiful and terrifying. It creates stars, planets, and life, but it also wields the power to destroy it all in the blink of an eye. Our continued exploration of the cosmos is not just a quest for knowledge. It's a fundamental act of survival. We must keep watching, keep learning, and keep appreciating the precious, fragile moment of calm we currently inhabit. Because we are the lucky ones living in a brief sliver of time, in a quiet corner of a very, very loud universe. Thanks for watching. If you found this journey into the cosmos as fascinating as I did, Make sure to like this video and subscribe for more explorations into the wonders and dangers of our universe. Stay curious.